Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to show you how to use the quadratic formula. What is the quadratic formula? The quadratic formula is used to help us solve any type of quadratic equation. Remember, the quadratic form is ax squared plus bx plus c. The quadratic formula looks like this. X equals opposite of b or negative b plus or minus the square root of b squared minus 4ac all over 2a. The really nice thing about the quadratic formula is that it's able to solve any type of quadratic equation, like I said, but it helps us because sometimes if we're solving a quadratic equation, we like to use other methods like completing the square or factoring, and if something cannot be solved by using one of those two methods, we can always rely on the quadratic formula to help us give us our answers. There's even a song to help us remember this formula. It goes like this. Opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Hopefully if you sing that song to yourself a couple of times, you'll be able to remember the quadratic formula for whenever you need it. First, let's talk about this thing called the discriminant that's found inside of our quadratic formula. Underneath that square root is that portion b squared minus 4ac. This is known as the discriminant. The discriminant is helpful because if we look at just this piece underneath that square root portion, it will actually tell us what type of roots or what type of solutions we will have for our equation. There are three options. The first one is that if your discriminant is greater than 0, that means that we are going to have two real roots, and those could be rational or irrational. Quick reminder that rational means that it's a number that could be written as a fraction of some sort, or a decimal that has a pattern to it, so it repeats itself, or it terminates, which means that it ends. If it's less than 0, that means that there's a negative that shows up underneath that square root sign, and that leads us to two imaginary roots. The simplest way to describe imaginary roots is when you have negatives underneath the square root sign. If you try to type that into a calculator, you're not going to be able to evaluate that. And so they don't become real answers anymore. They become what we call imaginary. If it's equal to 0, that means that there's going to be one real solution out there somewhere. And that, again, could be rational or irrational. Let's do some practice with just finding the discriminant and stating what type of roots the equation will have. So for this first one, I have 2x squared plus 4x minus 4. The discriminant, again, is that portion b squared minus 4ac. So for this equation, my a is equal to 2, my b is equal to 4, and c is equal to negative 4. Plugging it into my discriminant will look like this. 4 squared minus 4 times 2 times negative 4, and I get 48. 48 is greater than 0, so that means that this will have two real roots. Looking at this example now, we're going to solve this equation using the quadratic formula. So we have x squared minus 8x plus 15. For this problem, a is 1, b is negative 8, and c is 15. Plugging it into the quadratic formula looks like this. Opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 15, all over 2 times 1. It looks like a lot when we plug it into our quadratic formula, but if we start to simplify, especially if you start looking at just that discriminant portion, it makes this become a lot simpler. So when I simplify, I get 8, because the opposite of a negative is going to make that become positive, plus or minus the square root of 4 all over 2. The square root of 4 is 2, so now I'm left with 8 plus or minus 2 all over 2. So I have two equations to solve here. I have 8 plus 2 over 2, and I have 8 minus 2 over 2. So my answers are going to be 5 and 3, because 8 plus 2 is 10, 10 divided by 2 is 5. 8 minus 2 is 6, 6 divided by 2 would be 3. Looking at this next one, I have x squared minus 6x plus 4. For this problem, a is 1, b is negative 6, c is 4. Again, plugging it into my quadratic formula looks like this, and you can see that it simplifies in the middle there to 6 plus or minus the square root of 20 over 2. Now the square root of 20 is not going to be a nice number if I actually were to square root that. Now we can break apart square roots, and we can break that 20 apart into two numbers, 4 times 5. The reason I chose 4 and 5 is because 4 is a perfect square number that I can actually square root. And that's why on the next step you see I have 6 plus or minus 2 times the square root of 5. That 2 came from me square rooting 4. The 5 has to stay underneath the square root sign because I can't simplify that at all. Now to simplify this piece a little bit, I look at that 6, the 2 on top, and then the 2 on the bottom, and I can take a 2 out of all of those numbers, and I get 3 plus or minus the square root of 5. Again, I'm not going to get nice numbers if I actually evaluate this on my calculator. So my two equations to try to solve would be 3 plus the square root of 5 and 3 minus the square root of 5. If I try to type those into my calculator, you're going to get really long, irrational numbers. So those decimals are going to continue to go on forever, even though your calculator is only showing you a small portion of that number. So when we have problems like this, we just round our answers. So I get 5.24 and 0.76. Let's try a challenge problem. For this one, I have x squared plus 6x plus 10. A is 1, B is 6, and C is 10. If I plug this into my quadratic formula, I simplify and I get negative 6 plus or minus the square root of negative 4 over 2. See that negative underneath the square root sign? That's going to tell you that your discriminant is going to lead you to imaginary roots because we have a negative underneath the square root symbol. Whenever we have a negative like that, we can always pull it out. So we can imagine that that's actually like negative 1 times 4. And the square root of negative 1 is represented by I, our imaginary number. The square root of 4 is 2. So I simplify that to say negative 6 plus or minus 2i all over 2. And that's equal to 3 plus or minus I. Again, because I can take a 2 out of all of those whole number pieces. So the two equations I have are 3 plus I and 3 minus I. Now because I represents an imaginary number, I'm not actually able to evaluate these any further than this. So because it was less than 0, that discriminant, that tells us that there were imaginary roots and we're not able to evaluate these even further. So we just leave it as 3 plus I and 3 minus I. Or you can always keep it as that combined unit, 3 plus or minus I. If you're ready to give it a try, I've created a practice quiz on a website called quiziz.com. And it is a multiple choice platform where you can go and practice the skill you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.